Now, there are also aggregate functions in SQL. So you can do things like count the number of rows that meet a certain criteria, calculate the minimum, maximum, sum, and average of a particular column. Let's take a look at a few examples. So here, this table is showing you the different functions. So we have count, minimum, maximum, sum, and average. So let's say we want to count the number of products that we have in our product table. So the syntax for that is select count pcode from product, and that'll return you the number of products that you have. You could specify additional criteria to this count. For example, here, select count p price from product where p price is less than 10. So this query would answer the question, how many prices do we have that are less than $10? Right? Similarly, here we can do select count distinct vcode as count distinct from product. So here we are counting the number of unique vendor codes that we have in the product table. And it turns out we have 6 unique or distinct vendor codes in the product table. Okay. Here's an example of minimum, maximum. So select max p price as max price, and that gives it the column name max price. Min p price as min price from product. Right, so this gives you what is the most expensive and the least expensive prices in the product table. Similarly, you can do sum. So here we are selecting sum customer balance as total balance from the customer table. Here we are finding out the average price, average product price as average price from product. So fairly simple syntax here. Now let's go into group by. So again, to go over the typical syntax of a SQL query, we have select, from, where, group by, order by, right? And we can have a having in between. We look at having later as well. So recall our two tables, the vendor table and the product table. A vendor can supply 0 to many products. A product can be supplied by 0 to one and only one vendor. Okay. So in this query, let's say we want to get results that show us the different vendors, the number of products that each of them is selling, and the average price of the products that they are supplying. How would you get this result? Well, here is the query for that. So we need 4 columns. We need vcode, vname. We need the count of the number of products, right? So we have count pcode as numprod. We are simply naming the column numprod. And we want the average product price as average price, right? So now if you think about it, we can count the product code and we can calculate the average of the product prices, But what are we grouping by? What are we grouping by? We are grouping by the vendor, right? So in this case, that is why we specify group by vcode, vname, right? In other words, we want these aggregated numbers, the count and the average are aggregate functions. We want these aggregated numbers and we want them grouped by the vendor, right? So for each vendor, we want the count and the average price, right? Notice that if you include an aggregate function such as count or average price in the select clause, but you omit the group by, then SQL will generate an error. Okay. So whenever you have an aggregate function in the select clause, you should specify what you want to group by. In this case, we want to calculate the number of products per vendor. We want to calculate the average price as well per vendor. Therefore, in the group by, we specify vcode, vname. All right, the rest of the query looks familiar or should look familiar by now. So we have select vcode vname, count pcode as numprod, average pprice as average price, from product join vendor on product.vcode equals vendor.vcode, right? So vcode is the common column here, and it's the foreign key in the product table, right? So we are joining the two products, the product table and the vendor table. Product join vendor on product.vcode equals vendor.vcode. Lastly, we are ordering by vname, right? So we're sorting the results in ascending order by the vendor name. Okay, so that's the syntax, and these are the results of this query. Now let's say we want to have something like this, where we have the same two columns, vendor code, vendor name, and we have the number of products and average price, but we also want total quantity, right? And quantity appears here, the quantity on hand, right? So in this case, we would be summing the quantity on hand, right? So in this case, it's simply a matter of adding an additional column to the select clause. So let's read the syntax. We have select vcode vname sum quantity on hand as total quantity, count pcode as number of products, average product price as average price, product join vendor on product.vcode equals vendor.vcode, right? And then group by vcode vname, order by vname, right? Fairly simple syntax, fairly easy to understand. We're joining these two tables, getting aggregated data grouped by the vendor. Okay. Now the having clause. The having clause operates very much like the where clause, except that it is applied to the output of a group by operation. Okay, so in other words, let's say in this previous example, we only wanted to see those rows where the average price is greater than 100, right? In that case, we would not be able to filter it in the from clause. We would have to add a having clause here, which would filter the results of the group by query. So we would say all of this group by vcode vname having average pre-price greater than 100. order by vname. Okay, let's take a look at an example. Again, try to remember this order of the syntax: select, from, where, group by, having, order by. Okay. So again, to revise this, the having clause is applied to the output of a group by operation. For example, here, this is a simple example: select vcode, count pcode as numprods. Again, we're using count, which is an aggregate function, which means we need to specify the group by clause, right? So select vcode, comma, count pcode as numprods. This is simply the column name. From product, group by vcode, having average p price greater than 10. In this case, we are specifying that give me the number of products for each vendor, because we are grouping by vcode. And oh, by the way, only give me those results where the average p price, average product price, is greater than $10. And order by vendor code. So we get 2 rows as results. Only these 2 vendor codes have an average product price of less than $10. Okay. Here's another example. Now this is a more complex example, so I'd like you to understand this thoroughly. There are a few things going on. The first thing to note is that in the having clause, you have to specify the full formula. All right, even though you used the same formula here and called it total cost, you cannot refer to tot cost here in the having clause. You have to write out what you want to filter by. Okay. So now let's take a look at what this statement does. So the first thing it does is it joins the product and vendor tables using vcode. Right, and we can see that here. Product join vendor on product.vcode equals vendor.vcode. Restricts to only the rows with a discount greater than 0. Right. So where p discount greater than 0, groups the rows into collections based on vendor code and vendor name, right? So we are selecting vcode vname sum product quantity on hand times the product price, and we are calling that expression total cost. From product join vendor, where p discount greater than 0, group by the vendor having this total cost greater than 500. Order by also uses the full formula. So order by the total cost again and in descending order. Okay. So there are a few things going on here. Again, we're joining the product and the vendor table. We are restricting the rows, only those rows with a discount greater than 0. So that's done by the where clause. We are grouping by the vendor, right? So the vendor code and the vendor name. We are aggregating the total cost of products in each group, right? So this here is the total cost of products. We are aggregating by vendor. And we are restricting to only those rows where the total exceeds 500. So you want to say sum, the formula for total cost is sum quantity on hand times price greater than 500. And we are listing the results in descending order. So DESC is the keyword there. by total cost, right? Here, okay? So the thing to note here is that the syntax used in the having and the order by clauses, you should specify the column expression used in the select statements column list rather than the column alias. In other words, we cannot say here having tote cost greater than 500 and order by tote cost descending. No, you have to fill in the full expression. Okay, this is just one of the things that's unique to SQL, is you cannot use the column alias that you've used in the select statement. You have to use the expression that you've used and fill it out here. Okay. Now, some DBMSs will allow you to use the column alias, but most of them do not. Okay. So that's having in a nutshell. Now, if you are able to understand everything in this query, then I would say you have come the right way for this chapter. This query has all the clauses, or at least all the main clauses. So we have select, from, where, group by, having, order by, right? And we're joining two tables here, okay? Now let's move on to discussing subqueries. Subqueries, as they sound, are queries within queries. All right, so we have an inner query within an outer query. The inner query is embedded within an outer query. So what ends up happening is that the inner query gets executed first, and then the output of the inner query is used as the input for the outer query. So let's read through the key characteristics of subqueries. A subquery is a query inside another query, is normally expressed inside parentheses. The first query is known as the outer query. The query inside is known as the inner query. The inner query is executed first. The output of the inner query is used as the input for the outer query. And the entire SQL statement, meaning the full inner plus outer query, is sometimes referred to as a nested query. Okay. So there can be, the inner query can be embedded in different clauses. We can have where subqueries, in subqueries, having subqueries, and so on, right? So let's take a look at a few examples here. Now, this is a fairly simple example of a subquery where we have the inner query in the where clause of the outer query. Now in this query, what we're doing is we are finding out all the products from the product table that have a price greater than the average price. Okay, so the inner query gets the average price of all the products from the product table, and that's this part here. Select average price from product. And then the outer query gets the product code, the product price from the product table where the price is greater than or equal to the average price. Okay. Now, the thing to remember about subqueries is that the inner query can run independently from the outer query. In other words, if you take this inner query and run it all by itself, you will get a valid result. Okay. Later on, we'll look at something called correlated subqueries, and that's not the case in correlated subqueries. So here are the products that have a product price that is greater than or equal to the average price. Okay. This is a more complex example of a subquery. In this example, what we want is the list of customers who have purchased a product with the description that contains hammer or saw. All right. So the way we've structured this query is that first we get all the P codes, meaning product codes, where the description, the product description, is like hammer. And if you remember this wildcard character, now if you place the wildcard character both in front and back of the word, it will look for all descriptions that have the letter hammer in them. And the letter hammer could have anything before it or after it. Okay. Similarly, so we use the keyword or, description like saw. Okay. So the inner query runs first. As you remember, the inner query gets all the product codes that match these descriptions. And then the outer query runs. Now the outer query joins three tables, right? We have the customer, join invoice, join line, join product. Okay, so we are actually joining four tables, not three tables, four tables, because we ultimately want to get to the customers, right? We start off with the product descriptions, and then we want to get the customers. Okay, so we join customer on invoice, and we join it on the common attribute, that's customer code. We join invoice with line on invoice number, that's the common attribute. And then we join line with product on product code. That's the common attribute between line and product. Okay. One last thing to note about this query is that we are selecting distinct customer codes, right? In other words, it could be that this particular customer has bought such products multiple times. So they do appear multiple times. They have multiple lines with this product description. We only want to select them once. Hence, we use the keyword distinct here. Select distinct, customer.customer code, customer last name, customer first name, from customer join invoice on customer code equals invoice.customer code, join line on invoice number, join product on product code, where the product code is in our subquery. Select product code from product where description is like hammer or description is like saw. Okay. So believe it or not, this is a fairly common and simple query once you get to understand it, right? And so this query returns these results. Okay. Here is another subquery which uses the subquery in the having clause. Now the having clause, if you remember, having clause limits the results that the group by produces, right? So let's take a look at what this query does. Let's start with the inner query, right? We have select average line units from line, right? So we are getting the average number of line units present on each line from the line table. We are saying having some line units greater than this average. All right, so above average line units. Okay. So some line units is the total units, as you can see here. Select product code and some line units as total units from line. group by product code, right? In other words, we are grouping on the basis of product code, right? And we are summing all the lines for each of these product codes and then presenting the total here, right? Now we are limiting the results to only those product codes that have the total units greater than the average units. Okay, so this result set here has the total units, these total units, each of these is greater than the average line units. Okay, so again, fairly simple subquery which returns to you the products that have total units greater than the average line units. Okay. Now here's another subquery. In this case, the subqueries are present in the select clause itself. And again, remember that what we are looking at currently, these subqueries are not correlated subqueries, in that if you were to just run the subqueries by themselves independently, then they would produce valid results. They are not dependent on the outer query. The inner query is not dependent on the outer query. So here what's happening is we are selecting product code, product price, average product price from product as the average price, and we are also calculating the difference between the product price and the average product price. Okay, and we are calling that column diff. Okay, that's this column here. We are getting this from the product table. So look at the result that we get here. We get the product code and the product price. We also get the average price. Now the average price of all products from the product table will always be the same. You can see that here, right? It's the same for all rows because it's only one number as the average product price for all products. But further, we are calculating the difference between this product price and the average price that we got. And we are calling it diff, and we're displaying it here in the fourth column, right? So you can see the way diff is calculated is P price minus the average price. So 109.99 minus 56 something will give you 53 something. Where the average price is greater, for example here 14.99 minus 56 something will give you a negative number, negative 41 something, right? And so on. Okay, this again is an example of a subquery that's embedded in the select clause of the outer query. Okay. Now we come to correlated subqueries. The way correlated subqueries work is that the inner query executes once for each row of the outer query. The inner query is related to the outer query. It references a column of the outer query. Okay. Correlated subqueries can also be used with the exists operator. Okay. So in this example, which is taken from your textbook, we want to know which vendors we must contact to order products that are approaching the minimum quantity on hand value. Right, so we know, here's a snapshot of our data model. We know that a vendor can supply many products. Each product has a quantity on hand attribute and also a minimum quantity attribute, right? So we want to know the vendor code and vendor name for products with a quantity on hand that is less than twice the minimum quantity. Okay. So think about how you could approach this problem. Well, one way to approach it would be to go through the vendor table. So we have a vendor table with all the vendor information. We go through each vendor one by one. So we take the first vendor, then we look at the product table and we find out whether there exist any products that meet our criteria, right? And if there is at least one product that meets our criteria, then that vendor should be included in our result set. Okay. So in other words, we go through each vendor and we go through all the products of each vendor. If there exists at least one product that meets our criteria, then we want to select that vendor in our results. So then we would cycle through the second vendor similarly, the third vendor, and so on for all the vendors. So this lends itself to a correlated subquery. In a correlated subquery, the inner subquery runs on each row of the outer subquery. Okay, so for example, here in this case, we say select vcode and vname because those are the columns that we want, vendor code and vendor name, from the vendor table where exists meaning there is at least one row that meets our criteria. Where exists, select star from product where quantity on hand is less than twice the minimum quantity, and vendor.bcode equals product.bcode. Now, a few things to notice about this query here. First of all, this subquery here in parentheses depends on the vendor table, which is there in the outer query. Notice here that in the subquery, we are not using the vendor table. We're only selecting star from product, right? Because we are wanting to go through all the products for the first vendor that is selected from the outer query, right? So select star from product where quantity on hand is less than twice the minimum quantity, and we are joining using the vendor.vcode. This vendor table is the table that's there in the outside query, in the outer query, right? So in other words, this subquery cannot be run independently, right? If you were to copy and paste the code in this parentheses and run it by itself, it would not run because we are not selecting from the vendor table at all here, right? So we are dependent on the outer query. The inner query is dependent on the outer query, right? And it is linked to the outer query by this vendor table, right? In other words, we want to cycle through each vendor in the outer query's vendor table, right? And we want to cycle through all the products for each vendor, right? So the inner query cycles through all the products for the vendor that is selected from the outer query via this join, and sees if there are any products that meet this criteria, our criteria here. The exists keyword, that's how the exists keyword works, right? If there is at least one row that meets the criteria, in other words, where something exists that meets this criteria, then we select the vendor code and vendor name for that particular vendor. Okay. And if this criteria is not met at all, right? In other words, let's say we have a vendor XYZ and we go through all the products for that vendor and we find that there is no product that meets this criteria, then this condition will return false and that vendor code and vendor name will not be selected in our result set, will not be included in our result set. Okay. So let's go through the explanation given in the textbook to understand this once again. So we note that first, the inner correlated subquery runs using the first vendor, right? And the vendor is selected from the outer subquery. So we have a vendor table with vendor data in it, right? The inner correlated subquery runs using the first vendor. So we select all from the product table for that first vendor. If any products match the condition, and we know the condition, then the vendor code and name are listed in the output. The correlated subquery then runs using the second vendor, and the process repeats until all vendors are used. Okay. So that's how a correlated subquery works. Be sure to read the explanation given in the textbook as well. Right? We've just gone through it. So fairly intuitive. Next, we look at SQL functions. Now, SQL has a number of inbuilt functions. Right? Some of these are, for example, date and time functions. We have numeric functions, string functions, and conversion functions built into SQL. Let's take a look at some of these tables that are referenced on this slide. So this is the first table where we have some date functions, right? For example, date underscore format. Right? Date underscore format will format the given date in a particular way. %m, and by the way, this is case sensitive formatting. %m is different from %M. Right? They have different meanings. If you say format this date using %m /%d and %y, it's going to take that date and then format it as 2-digit month, the number of day of month, and then the 2-digit year. On the other hand, if you say %M, it's going to format it as the full name of the month. Right? And %Y will use the 4-digit year. Okay, so that's the date format function. Now, like this, we have several other related functions like year, month. Year will return you the year. Month returns you the month. Day, add date, date underscore add, and so on. Okay. Now, I would not recommend you memorizing each of these. Even in real life, you often have to consult a reference book for the DBMS that you are using to know the syntax and the functions that the DBMS offers, right? So you don't need to memorize these as such, but you should know what I expect you to know is the select from where group by having order by sequence, right? All right, here's the next table, and this we have some math functions like absolute value, rounding of numbers, ceiling and floor, and so on. Okay. The next table lists some string functions. So here we have some concatenation. And keep in mind that these functions might differ from DBMS to DBMS. So Oracle might implement these slightly differently than MySQL or SQL Server, right? So we have these various functions here. We have the substring function as well, which returns a part of a given string, right? And so on, right? Fairly easy to understand. Length of a string and so on. Again, here we have character, so to character, casting and converting, right? And so on. Okay. Again, you don't need to memorize these. Just know that they're there. And if you need to use them, consult the DBMS manual that you're using. All right, so lastly, we come to relational set operators. Now, set operators consist of three main operators. We have the union operator, union all, and intersect. Union will combine the rows from two or more queries without including duplicate rows, right? And the syntax is very simple. Query union query. Union all will do the same thing except that it retains duplicate rows. Okay. Intersect will only return rows that appear in both the queries. Okay. So query, intersect, query. Why do we need these? Sometimes we need to process the results from two different queries, and we need to come up with results that are only in both queries, right? Rows that appear in both queries. In that case, you could use intersect. There might be other scenarios where you could use a union or union all. Okay. Then we have the except operator, also called the minus operator, and it basically removes the rows that are there in the second query from the rows that are there in the first query. Okay, so it combines rows from two queries and returns only the rows that appear in the first query but not in the second. Okay, so here we see an example of union, the union operator. So this is our first query. This is our second query. So query 1, union query 2. Here are the results of the first query. We're saying select last name, first name, initial, area code, and phone number from customer. And we are selecting the same columns from customer 2, right? And if we union the two, now keep in mind, union removes duplicates, right? So duplicates don't appear in the union results, even though there may be duplicates here. Okay. Similarly, you could do an intersect between the two tables, and it would only return the common rows that are there in both the result sets. You could do minus, right? So it would only show you those rows that are there in the first results, the first query's results, and not there in the second query's results. It turns out there are 5 such rows. Okay. So lastly, we come to some tips for crafting select queries, right? So first of all, you should know your data, right? Obviously, you should know the database, the data model that you are working with, right? You should understand the data model fully in order to start writing any queries, right? You should know the problem, right? What is it that you're trying to answer, right? Why do you need that data? What are you going to use that data for? And what columns do you need, and so on, right? And then your book suggests that you build one clause at a time, starting with the from clause. Now, why do we start from the from clause? Well, the from clause tells you which tables you need, right? Select something, something from, and then there's the list of tables, right? So first identify the tables where your data exists, right? The select clause, your book suggests writing that clause later on in the sequence. Now, this is also somewhat a matter of personal preference, right? So you could, for example, identify the columns that you need first, right? So, but this is the structure, the general structure that is suggested in your book, okay? So that's pretty much it for chapter 7. It's a nice introduction to SQL. SQL is a fairly easy language to learn, right? And once you start doing the practice exercises and you go through the activity, you'll have a good understanding of SQL. Okay, so do read the chapter. Do go through the practice exercises on MindTap. Let me know if you have any questions. Good luck, and I will see you in chapter 8. Thank you.